So now you've acquired your image and you think you're done with that Western blot. Not really. There's a few things that we need to look on our image to make sure we can consider that imaging session complete. First, we need to make sure there's no signal saturation. Then we need to ensure that all of our bands have a signal-to-noise ratio above background, meaning the bands are strong enough so that we can actually quantify them. Last but not least, we need to make sure there's no artifacts on that membrane, such as bubbles or areas of the membrane that are darker than others due to uneven substrate distribution. So make sure you look for those and that they're not present so that you will have an accurate quantification downstream before you can consider that imaging session complete. In order for you to be able to accurately quantify your data, it is extremely important that no image manipulation was present at the time of image acquisition. So as you're saving your image file, double check to make sure that no binning or stacking were done during image acquisition. When you're adjusting the visual display of your image, you want to make sure that you have an accurate visual representation of your data. You never want your image to be misleading. What I mean by that is, perhaps on my image I have a faint band, and I adjust the brightness and contrast just enough so that that band doesn't even show. That is not an accurate visual representation of my data. That would be misleading. So as you're adjusting brightness and contrast of your image, make sure you always have that accurate visual representation of your data. There are several ways to analyze your Western blot data. One of the most common ones is called densitometry, and is based on trying to quantify the intensity in which your bands are displayed on the computer screen. If that is the way in which you decide to analyze your data, when you're doing your image adjustments, you need to make sure that brightness, contrast, and linearity are consistent amongst all of the images in one given project. That's going to ensure that your densitometry is performed accurately. Unfortunately, software can also manipulate your data. You need to be careful with that. A lot of that type of manipulation is going to come from different forms of background subtraction or image adjustment, for example. So before you start analyzing your data, make sure you educate yourself and that you fully understand all of the different options present in any given software. A simple solution to try and avoid adding variability to data analysis is to use a software instrument pair that allows you to quantify the raw data. Meaning that instead of trying to quantify how strong a band looks on your computer screen, you actually quantify the intensity of each individual pixel that was registered upon image acquisition. That significantly increases how robust your data is. Similarly, if you can use a software that was specifically designed for Western blot analysis, such as it's the case of Image Studio and Empiria Studio, you're going to get more accurate data at the end of the day. Another solution that you may want to try and consider is switching your detection chemistry from chemiluminescence to near-infrared or NIR Western blot detection. By doing so, you will bypass having to deal with all of the variables that come with the enzymatic reaction that happens between your enzyme and your substrate. If you'd like more information on that, please refer to our Lambda U course on near-infrared Western blots and to all of the additional resources we have on our webpage.